The new science curriculum puts working scientifically at the heart of primary science. And there's a much more increased focus on children learning to work as scientists rather than just focus on acquiring scientific knowledge, as well as the science knowledge that they're going to develop over their time in primary school. This sort of makes sense because if a child in year 3 has really got to grips with rocks and can tell you the names of the types of rocks, it probably follows that when you speak to them about it in year 6, they could well have forgotten it. Unless that scientific knowledge is being used on a regular basis, we will often forget it. If you are going to revisit that topic later in your education, you can review and remind yourself of that knowledge. The real key thing here is that we're trying to create scientists in primary schools that can develop all those skills of being good scientists and take them with them when they move up to secondary school, so they really are ready for that next level of science education. The kind of skills that we're talking about are their ability to ask questions, to think of how they're going to go about finding the answers, and to communicate the findings that they get through their experiments and different types of inquiry. With the new curriculum, we are no longer expected to take our most able pupils and move them on to further scientific knowledge. Instead, we've got really clear guidelines of what it is they need to learn within that year. So you can stay working within the science knowledge that's expected for that age group, but you can develop the children's skills in working scientifically to even higher levels and therefore create even better scientists. So for example, children in year 1, as they're developing as scientists, you'd want to encourage them to make more measurements and use more data to help answer their scientific questions. As we move on to year 5 and 6, we can add that extra challenge of repeat readings and mean averages, and children independently drawing line graphs and scatter graphs to look for trends in data. Also, this is a great opportunity for children to develop their more formal written work and use basic skills from literacy when they're reporting and maths in analysing their data or in having more accurate measurement, to make sure that they feel challenged and that they are working as a scientist at a really high level. In all my science lessons, I have 2 objectives now. I have the learning objective, which is the science knowledge that they're going to acquire within that lesson or develop or even apply to a new situation. But I also have the skills objective. The second objective is the skills objective, and that is an area of working scientifically that we will really focus on within that lesson. It may be that we use several skills of working scientifically across the lesson, but there will be one particular area that we really focus on developing and improving in that period of time. The one thing I don't do though is share the objectives with the children. By telling the children what you're going to learn in the lesson, you're taking away that element of curiosity and what we're going to discover. So instead, the children are given a big question, and our mission within the lesson is to use different types of inquiry to try and find the answer to that big question. Those big questions are planned carefully so that over the periods of, let's say, a half term, all the learning requirements of the curriculum are covered. What we also do is at the start of a topic, we consider what the children already know about this and what they would like to find out. And in doing that, that sometimes generates some of the children's own big questions, which can be incorporated into my planning so the children have a say in the types of inquiry that we carry out. With regard to assessing children's progress in science, I've found that using the teacher assessment to look at subject knowledge works really effectively, and that can be through formative assessment, questioning, and of course reading what they've written and assessing in that way. However, with working scientifically, we've found in using peer and self-assessment, that really helps to develop skills that the children have in these areas and move them on quite rapidly. In terms of assessment, I find that assessing children's subject knowledge in science is best done by the teacher through formative assessment methods, questioning, and of course reading the words they write, and that really gives you an indication of any misconceptions or just their understanding of the science covered. However, we've found out in using working scientifically as a focus for peer and self-assessment that this is a fantastic way to really move children on rapidly as they really reflect on what they've done well and what would make their work as a scientist even better. The other good thing about the new curriculum is we've acknowledged that not all scientists do fair tests. In fact, in real life, there are lots of different types of inquiry that scientists carry out to find the answers to their big questions. So instead, now we have a range of different inquiries that we cover across primary schools. We have identifying and classifying, fair tests, comparative tests, research, observing over time, and pattern seeking. Children need to be regularly exposed to all these types of inquiry so they can develop skills in all types of inquiry to help find the answers to their questions. So, if you're wanting to find out more about these types of inquiry and what that looks like in the classroom, we've produced a series of shorter videos that look at each one in turn and give you some ideas about how you might approach that with your children.